Let G dot be a group and H be a subset of G, then H is a subgroup of G. If AB are two elements of H, implies AB belongs H. For all A belongs H, A inverse also belongs to H. AB belongs to H implies AB inverse belongs to H, and in option D, AB involve AB in H, then B inverse A inverse in H. After seeing options, you can directly tick the answer C. But other options, why fail? You should know these one. Because if we are picking any two elements, then all four properties will be satisfied for for a group: closure, associative, identity, and inverse. If a star or any other operation is given, it is binary operation. There is no need to check closure property, because saying that binary operation, we say operation, a binary operation, whenever it satisfies closure property, otherwise not. If it is simple an operation, then we need to check closure property, otherwise there is no need to check. But here dot is a operation, and normally because J dot is a group, so it is binary operation and it will satisfy for properties. Now H is a subset of G, and we check or say H will be a subgroup of G when H has same operation induced on H, induced on G. So for option A, if we are picking two elements from H, implies that AB belongs H. It is only closure property satisfied here, but not inverse and identity element we cannot satisfy using this condition. So option A is not necessary part. For option B, if for all, if A in H, then A inverse belongs H. Means for each element have inverse in H. So we can say H is a subgroup? No, because of we can't prove closure property. Closure property because of elements are coming from G. It doesn't mean they will satisfy closure property. Yes, they will satisfy closure property, but it may be identity they cannot prove using only this condition. Option C is correct, and we know that option C is one step test for subgroup. Now where is option D is fail? If AB are in H, then B inverse A inverse also H. It means that this property is saying elements have closure property, elements satisfying closure property, but particularly we say closure property for all elements, but they are combining only inverse element. Suppose A inverse B, and this is element another element C. Suppose this is H. If we are picking an element A and B, then B inverse A inverse in H. But if we are taking A and C, then according to this condition, C inverse A inverse in H, but C inverse is not present in this set. So closure property partially satisfied here, but not for all elements. So only correct option is C.